Have a good day. This is Pavel and Jipolit, BSIT2A. Welcome to Addressing the Network or IPV4 Chapter 6. Internet Protocol version 4 or IPv4 is the fourth version of the Internet Protocol or IP. It is one of the core protocols of standards-based Internet working methods in the Internet and other packet switch networks. IPv4 was the first version deployed for production on SANET in 1982 on the ARPANET in January 1983. It is still used to route most Internet traffic today, even with the ongoing deployment of Internet Protocol version 6 or IPv6, its successor. IPv4 uses a 32-bit address space which provides 4, 294, 967, 296, and R232 unique address, but large defines and enables Internet working at the Internet layer of the Internet Protocol suite. In essence, it forms the Internet. It uses a logical addressing system and performs routing, which is the forwarding of packets from a source host to the next router that is one hop closer to the intended destination host on another network. So IPv4 is a connectionless protocol and operates on a best effort delivery model, in that it does not guarantee delivery, nor does it assure proper sequencing or avoidance of duplicate delivery. This aspect, including data integrity, are addressed by an upper layer transport protocol such as the Transmission Control Protocol or TCP. So in this chapter, I would be able to explain the structure IP addressing and demonstrate the ability to convert between 8-bit binary and decimal numbers. So IPv4 addressing. So what is IP addressing? An IP address is a unique number address used to identify a device on a network. Every device connected to the Internet must have an IP address to communicate with other devices. Xbox games, cell phones, tablets, cars, fax machines, etc. An IP address acts as a telephone number or a car registration plate. It shows ownership and location. IP address allows a device to communicate and be located by other devices on the connected World Wide Web. So recently, there are two types of IP addressing, the IPv4 and IPv6. So IPv4 address is made up of 32 binary bit switches divided into a network portion and a host portion with the help of a subnet mask. So 32 binary bits are broken into 4 octets. So 1 octet is equal to 8 bits. Each octet is converted to decimal and separated by a period or dot. So how IPv4 address look? So IP addresses have two common formats. IP version 4 addresses are comprised of 4 numbers, only segments separated by dots. Like for example, 127.0.0.1. Then another example is 253.17.35.2 and 192.168.10.1. 108.105. So the value in its octet range from 0 to 55 decimal or 0. So 8 ka 0 and is equal to in binary into 8 na 1. So below is how binary octets are converted to decimal. So the rightmost bits or less significant bit of the octet holds of a value of 20. So the bit just to left of the holds a value of 21. This continues until the leftmost bit or most significant bit which holds a value of 27. So if all binary bits are 1, the decimal equivalent would be 255 as shown here. So ang 8 ka 1 is equivalent like this. Ang 1 is equivalent to 1 to 8, the first bit. Then second one is 64. Then another is 32. Then 1, another one is equal to 16. Another one is equal to 8. Another one is equal to 4. Then 0. Then 2, 1. So 1 to 8 plus 164 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 255. So that's the decimal. So, and this example below shows an IP address separated in binary and decimal. So 192.168.4.10, that's the decimal. Then ang binary is 11001 so forth. So that's IP version 6 addresses are more complex. IPv6 addresses are comprised of 8 segments and it looks like this. So IPv6 uses 128 binary bits to create a single unique address on the network. An IPv6 address is expressed by 8 groups of hexadecimal, which is base of 16. Numbers separated by colons as in 2001, then then colon. Then groups of numbers that contains all zeros are often omitted to save space, leaving a colon separator to mark the gap. IP addresses are located by the Internet Service providers or ISP, which means they act like lenders who in turn get loads of IP addresses from the Internet Assigned Numbers Authority. Diana is a non-profit corporation whose main business is the control and coordination of IP addresses and so many other internets. It sounds more or less like the central bank loaning money to the commercial bank, which in turn loan it to individuals. Those ISP gets an allotment of IP addresses, load of them, and assigned IP addresses to every server and every internet user, computer, and other devices that logs on. So, how IP address works? To sum up it in plain, IP addresses are the numbers that identify devices connected to a network. If your device only needs access to a local network, it can be identified with an address that has only a local context. These are called private addresses. But when your device needs to access services on other networks, so it needs to use a unique address. So IP address works like a house number or phone number, which is what you need as a contact. If you want a reply to a letter, you need a house number, and so also goes to phone number. So in some cases, an IP address can be translated from a private address into a unique address at the border between your network and your ISP network. So sounds more like a post office box or a shared house where a group of people receive letters without owning the box, or a company phone number with an extension to different offices or departments. So this technology is called network address translation, or NAT. Earlier, we said for you to send and receive email on the internet. So your connected device, as your laptop or PC, needs an IP address. For this process to work, your IP address has two parts. The first part of an IP address is used as a network address, and the last part of a host address. For this process to work, so if you take the example, the 192.168.105.148 and divided it into these two parts, you get the following. So 192.168.13 is the network, and 123.123 is the host. So the network part of the address is likened to the house address, so number or postcode. The host part of the address is likened to an individual or person's name on the mail who lives in that home. In essence, an IP address is a unique number used to identify a device or machine on the internet. And in my conclusion, IP addressing structure, its device on a network must be uniquely defined. At the network layer, the packets of the communication need to be identified with source and destination address of the two-end system. With IPv4, this means each packet has a 32-bit source address and a 32-bit destination address in layer 3, header with IPv4. These addresses are used in the data network as binary patterns. So inside the devices, the digital logic is applied for their interpretation. For the human, a string of 32 bits is difficult to interpret and remember. Therefore, a dotted decimal format is used to represent in IPv4 addresses. So that's all for this chapter 6, addressing the network IPv4. So I hope you learned something from this video, and thank you for watching.